Let us begin with the uses of mathematics. So, this is the last part of this module. Mathematics has so many uses. We will illustrate this by drawing from statistics, some tools that can help us with understanding data sets. Did I mention that one of the most important aspect of mathematics in the modern world is your appreciation of the existence of mathematics in anything and everything we do, because most of young people these days, only few loves math because of it's certain a certain level of difficulty in manipulating numbers. But mathematics in the modern world is trying to emphasize to us that mathematics can be a tool, mathematics can be a language, and mathematics is everywhere to help us understand like the movements of the planets, the perfect stability of its location, and many things in the world. And for me, as a mathematics teacher, I would like to say that mathematics is easy, though it needs you a lot of thinking. But when you get into it, you will love mathematics. Okay, so mathematics has so many uses. So we will get some examples from statistics to help us understand some data sets. So this is how this is where we begin to compute some things. Okay, so don't worry, I'll be guiding you through it, and we will not be solving a lot in this subject because it's more on appreciation of mathematics around us and how we can use mathematics wherever we are. So practical uses of mathematics, it has only four here, but I think you have plenty of uses that you can add here. This is so generalized. And so the first is mathematics helps organize patterns in the world. Mathematics helps organize patterns in the world. Second, mathematics helps predict the behavior of nature and many phenomena. So I believe pag-asa and the volcanic people, they are specifically relying on numbers to give them hint of what is happening, what is going us or around us. Letter C, mathematics helps control nature and occurrences in the world for our own good. And D, mathematics has applications in many human endeavors. Okay, those are general, broad, practical uses of mathematics. So look at this. This is an example of phyllotaxis, the study of leaf arrangement. Notice that each of these leaves receive the best amount of sunlight, and that is the emphasis. Examples of the uses of mathematics in social phenomena. So in the following examples, we shall use statistics to illustrate the uses of mathematics in discovering patterns in social phenomena. I believe that this is not new to you because you have passed probability statistics in high school, in senior high school. Example 1.2, frequency distribution of mobile phone ownership. So the first thing is frequency distribution. A survey about mobile phone ownership was done in a subdivision with 50 households. Produce a frequency distribution to display the pattern of ownership based on the collected data shown below. So number of mobile phones per household. So we have these. Probably house number one has two cell phones, house number two has five cell phones, house number three, no cell phone at all, house number four, five cell phones. So look at that. These are all the gathered data from the 50 households in a subdivision. So how to make our problem is how to make a frequency distribution. I like how the author presented the frequency distribution here. It's just so easy. The solution. The raw data collected about mobile phone ownership by themselves are not too helpful because in raw form, they do not tell us the pattern of mobile phone ownership in this town. To see the pattern of ownership, we are to produce a frequency distribution table and a histogram. Notice, okay, maybe by just looking here, you can say that majority, if I am right, majority of the households has 5 cell phones. Some of them has three. Um, Only few got 4, got 6, and 7, and countable values of those who have 1 cell phones at home. So you can just bana-bana here. But when we have a frequency distribution and a histogram, we can make a table to make all the cell phones or the frequency most reliable to look at. Okay, so there is a 0, 1, 2, 3, 4, 5, 6, 7. 7 is the highest cell phone number of cell phones that you can see, that you can observe in a household. So how many household F that owns X mobile phones? So 0, there are 3 households that has no cell phone. There are 2 households that has 1 cell phone at home. There are 5 households that has 2 cell phones at home, and there are 9 households that has 3 cell phones at home. There are 5 households that has 4 cell phones at home. There are 18 households that has 5 cell phones at home. There are 5 households that has 6 and 3 households that has 7 cell phones. So the first column displays excuse me, 0 to 7. In statistics, this is the sample space, the set containing all possible outcomes of the experiment. Remember probability, the sample space, event, and many things. So they are events, and as a whole, they are called sample space. So list of all possible outcomes is just 0 to 7 because no household has more than 7 cell phones. The second column shows the frequency, just counting the households, the number of households that has this possible number of cell phones. Did you get that? So, pila ka buok ang 5 cell phones in their household? Let's try to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And that is correct. That is how to make frequency distribution. You list all the possible outcomes on the left side and count them on the right side. So this is the histogram, which is the better picture now. In this table, the frequency distribution table, or this histogram. Okay, we love to look at the histogram, of course, because it tells us, most of the houses have 5 cell phones because it's the highest bar in the histogram. That's correct. That's a very good observation. So, based on this histogram, we can clearly say that most of the household has 5 cell phones. But let us take a look on the next example. So the first example here, we use the data to make frequency distribution and a histogram. I will show you later how to do it in the Microsoft Excel. Finding the weighted mean. Oh, again, weighted mean, solving. Okay, return to the data on mobile phone ownership. On average, how many mobile phones does each household own? Okay, so how will you solve the mean for this? Of course, we know that. We just simply add all of them, and then divide them by 50. Great, that's one way to get the mean. But this time, we will use the weighted mean. Since we have already a table here, we can use this to get the weighted mean. So the solution, the measure of central tendency shows the mean quantity of my mobile phones owned by each household. So there are three measures of central tendency. Okay, a short statistics class. Measures of central tendency, mean, median, and mode. Mean is the average. Median is when you arrange all the data and get the middle value. That's the median. And mode is counting what is the most apparent value. So in our case, the mode is 5. The median, if we arrange this, try to notice 3, 5, 5, 10, 19. Okay, so when we arrange this, majority will be 5. So the median is also 5. Oh, the middle value is approximately 5. But we need to find the average. Among the measures of central tendency, the mean is the most appropriate. Why? Because it caters all the value. Diba? Kung median, it's biased. What if the the first is the first part is so low and the last part of the data is so high, and then you only get the middle value? That's bias. When we also look at the mode, the most occurring. But what about those on the inside and those, yeah, they are biased. But when we say mean, all the numbers, all the scores, that's why the teachers are using average in school, because all the scores are contributory to that value. So we can obtain this in two ways. Both will produce the same numerical output. The first is the one I said. You add all of those values, 50 of them, and then divide them to 50. But we can use the weighted mean. This is the second way. The weighted mean is the summation. Okay? If you are new to mathematics, you're hearing alien words this time. Okay, summation of x sub I times frequency sub I, f sub I, divided by the summation of fi. So how to do that? You only need to have 3-column table. So first, number of mobile phones 0 to 7, number of household that owns mobile phones, that is 1, and the summation. Okay, notice of xi times fi. Class, this is multiplication of the frequency and the number of households. So frequency, this one, and yeah, the number of households and the number of phones. So 0 times 3 equals 0. 1 times 2 equals 2. 2 times 5 equals 10. 3 times 9 equals 27. 4 times 5 equals 20. 5 times 18 equals 90. 6 times 5 equals 30. And 7 times 3 equals 21. Again, this is the product of these numbers times these numbers. So individually, by row, you solve them. And then the next step is you get all, or the summation. That means you add all this and then get the value. And then you add also these numbers and get the value. So if you notice, 0 plus 2, 12, 27 plus 12 plus 20. Let's start with this. So 2 plus 7, 9. And then plus 1, 10, 0. 1, 2, 3, 4, 5, 6 plus 9 is 15 plus 5 is 20. That means we have 200, and this one is sure enough because 50 households man to, so dapat 50 dyan ni siya. So 50. We just need to divide them, 200 divided by 50, and there we get 4. So we can conclude that on average, each household owns 4 mobile phones. Okay? So that is how to get the weighted mean of the data. We have also another example, finding patterns and predicting outcomes. So mas mahirap, mas madugo. Finding patterns and predicting outcomes. So the following table shows the total coffee consumption measured in 10,000 bags in the Philippines from 1990 to 2016. Okay, so we have from 1990 to 2016. What is our problem that we need to solve? We need to produce the country's projected yearly coffee consumption from 2018 to 2021. How to do that? Yes, you need to go to the coffee. Where should we go when we need to find this one, coffee consumption? To the stores, to the malls, and then we will get the value of the coffee consumption in 2018 to 2021? No. We can answer this using the patterns seen in this data. So we have already a data from 1990 to 2016. So we will just use this data to predict the possible yearly coffee consumption from 2018 to 2021. So when we say prediction, that is not that is not kanang so ba tumpak jud na mao jud na ang makuha nato for 2018, mao jud nang mahitabo for 2021. Prediction can sometimes be true or false, okay? But at least we can have the importance of prediction. We can have a clear picture of the possible consumption and what this means to business owners, to coffee makers. So they will have also something to come up with, like, oh, dapat in 2021 ing ani kadaghan atong i-produce na coffee because the possible consumption of people will be like this. So that's how statistics work. So how to do that? So what do we do? How can we estimate Philippine consumption of coffee from 2000 to 2021 using the information presented to us? So we have what we call linear regression. Okay? Linear regression is used to predict data. So, is what can help us with projecting coffee consumption. First, there are steps that we need to follow in order to accomplish the linear regression. Okay, so scatter plot. This is just a graph. Second, we draw the line of best fit. Okay, I will show you that later. And this line has an equation and can be obtained through least squares regression line. So there are SPSS, Excel, and other AMOS, other statistical tool that we can use this, but this time we will use Microsoft Excel. So we shall not compute for the slope and intercept of this line manually. Instead, we will use the linear regression function available in a spreadsheet software. The one we shall use is Microsoft Excel. And then the third, we will use the equation to project the Philippine coffee consumption. So here's the scatter plot. Okay, so this is from Microsoft Excel. I inputted this myself. So this is first step. Make a scatter plot from 1985 to 2020. So, mao ni siya iyahang distribution of coffee consumption. The scatter plot shows two intervals of time where coffee consumption has strikingly different rates of increase in consumption per year. And from your judgment, from 1990 to 2005, okay, We will ignore this because the data points are so much different from the ones from 2006 up. So we will be using from 2006 to 2016 only in our next step. The linear regression equation is y equals 1.954x minus 1.281, and the estimate yearly coffee consumption from 2018 to 2021 measured in 10,000 bags of coffee is approximately, okay, uh, we will be using this value instead of these ones, but they are round off of that one in the bottom. So how to do this? This is the line of best fit, kani siyang line. And then this is the value from 2006 to 2016. So we just use the end value of the year, 6, 8, 10, 12, 14, 16, instead of 2006, 2000. By the way, if you will also use 2006, 2016, you will come up with the same value, okay, of the prediction, but different here in this value. Okay, so we can use 6 to 18. And the letter C, projection for years 2018 to 2021. So when you have this from Microsoft Excel, you can just input X. Kumbaga, this is your formula, 1.9547x minus 1.2811. This is the formula to get the value of y. So, y is the year, I mean the number of bags for our projection, and x is the number of year. And this is the constant 1.954 and another constant 1.2811. So, here, you just need to substitute x with 18, 19, 20, and 21. Then you get the output, this one, 33, 35, 37, and 39. And therefore, we can have projections of the coffee consumption. So if you have previous data, you can project the next data using linear regression. So I will let you take a look of this data here. So from the number of cell phones, yeah, households have, that are 0 to 7, I just make two columns for the number of cell phones, sample space, the available number of cell phones based on the data gathered, and the number of households that has that number of cell phones. Okay, and then I highlighted it and then insert, and when you click insert, you have the option to choose this one. But with Office 365, you can have recommended charts, and then you can select from one of them and edit some part, yeah, like that. And then you will come up with that graph. And then another one is the coffee consumption. I just type the values given in the book and make it here so that I can copy paste for the module. And since we are asked to have a scatter plot, okay, so 1985 to 2020, never mind this one, but I just get also this one. From this, you just highlight and then insert. Okay, you can use recommended charts and all charts, and you can use this XY scatter. Okay, when you click that, okay, it will automatically give you the chart. So that's okay now. And then after that, see that the trend line, the line, this one, this trend line. Oh, by the way, we will not be using this 1985 to 2005. So you need to make another set of data and get only from 2006 to 2008. So for me, I just use this one. I highlight from here and then right click to make a scatter plot, and then it gives me this one. When that comes out, this graph comes out, it has automatically this formula here on the left side. And then you just click add and then check trend line. Okay? And when you check trend line, this line will come out. So we have also already that 1, 1, and 2. First and second steps plus the formula. Notice this has this different formula because it's using the year. But if you are using 6, 8, 10, 12, 14, 16, 2018, or 16 and 18, the exact value that will come out is the ones that I'm using here. So class, do not worry to when you are doing this, just use Microsoft Excel. Okay, so for the examples, again, we have frequency distribution table. Okay, what we learned today from this frequency distribution table and the histogram. Next, how to get the weighted mean. Okay, multiply the two columns, get the sum of the two columns to the right also, and then divide them. And then finding the pattern and predicting outcomes, we can use linear regression, and there are 3 steps. Create the scatter plot, draw the line of best fit, and use the equation to project the Philippine coffee consumption. So I might give you 1 or 2 problems related to these examples. Just be sure that you have understood what I say and you can do it by yourself. So the apply and create will be given tomorrow again. We will have a quiz tomorrow after you can watch this presentation. So God bless you all. Thank you very much. I'll be making another video in Canvas to give you final instruction for our activities tomorrow and Thursday.